Welcome students. In yesterday's class I performed the evaluation of this particular question, integral -2 to 2 e raised to the power of -x squared over 2 times dx using Gauss Quadrature. Now a few questions were asked to me. First question is, how exactly was I able to apply the Gauss Quadrature to this integral with the interval being defined for -2 to 2. Now on the contrary, the Gauss Quadrature is only defined for the interval -1 to 1 f of x times dx, and the formula is given to be as sigma I is equal to 1 to n c1 times f of x1. I applied Gauss Quadrature to this particular function defined in this interval. Now how did I do that? I did that because of the definition of Gauss Quadrature. Let me just give you the following information. A term called as quadrature. Now you will come across this term quadrature. Now what exactly is this? Where you pick the points where the function is evaluated. So because of this particular definition, I was able to actually transform a function that is defined only in the interval -1 to +1 to a function that is to the interval -2 to 1. How am I able to achieve this? I'm able to achieve this by applying transformation. Now, what transformation did I apply to solve the question? I applied the following transformation, that x is equal to b negative a divided by 2 times z positive b positive a divided by 2. So this is the transformation formula where a comma b is the new interval, and if you remember, I also utilized z, and z is the variable in the standard interval. Right? Now how did I get the value of z? We are used in the 2-point quadrature z1 and z2, and remember w1 and w2 are the weights, and in the previous question I have taken w1 is equal to w2 is equal to 1. So these are the procedures that I have actually implemented to achieve the result. Now the all important question is, how did I find z1 and z2? So I'm going to demonstrate here how exactly I got that. By definition, we are actually aiming to solve Legendre polynomials. Okay. Now what are Legendre polynomials? They are sequence of orthogonal polynomials. Now for the Gauss Quadrature 2-point formula, we are actually interested in solving the second degree Legendre polynomials. Okay. Now the question is, what is the form of the Legendre polynomials? The form is 1 over 2 times of 3x squared -1. Now if I take, or instead of saying if, when P2 of x is equal to 0, we get 1 over 2 times of 3x squared negative 1 is equal to 0, which means 3x squared negative 1 is equal to 0, which means 3x squared is equal to 1, which means x squared is equal to x is equal to plus or minus root of 1 over 2 roots are there, negative 1 over root 3, and if this is sum x1 and this is sum x2, you get positive 1 over root 3. Now if you remember the previous point, we are actually associating these values x1 and x2 to z1 and to z2. So in other words, to find z1 and z2, we are taking the polynomial to be equal to 0. So that is the all important point to solve this question, integral negative 2 to 2 e raised to the power of negative x squared over 2 times dx. For this question, what are we going to do is, we are going to be transforming z1 to x1 and z2 to x2. Now why are we doing that? Because of the interval negative 2 to 2. I hope this clarifies. If you're trying to solve a question by applying the Gauss quadrature for any given interval, then you have to foremost understand this, the standard formula. So what is the standard formula? The standard formula is, the Gauss quadrature is defined only for the interval negative 1 to 1, and the function is given to be as I is equal to 1 to n with, you can either say wi or ci. So if I in the starting case I've used ci, so I'll just stick to ci of f of xi. Okay, so this is the standard definition. And what are we going to do? We are going to, step 2 is identify the new interval. So in this particular question, the new interval for our specific question is negative 2 to 2. So you get that point. And number 3 is, you apply the change. Apply the change of variable. So what are we trying to do when you say apply the change of variable? You are expected to transform the formula to convert the standard points to your interval. Originally we have z1 and z2. Now z1 and z2 have to be converted to x1 and x2 to reflect the interval. So in other words, we would be having x1 to be b negative a over 2 times z1 plus b positive a over 2, and similarly x2 is equal to b negative a over 2 times z2 plus b positive a over 2. So this is the transformation that you will have to apply. And the final step, I'm going to put the final step here, you perform the evaluation. You evaluate the function at these new points and then you sum them up as per the Gauss-Legendre formula. Okay, so that will be the conclusion for the question that the students have asked, why or how I'm able to apply the Gauss quadrature formula for this particular question. Please like, share and subscribe. Thank you.